Hey guys, so in this video we're going to be talking about the law of cosines. Now in the last video we talked about the law of sines, which looks something like this. Sine A over A equals sine B over B, and same for sine C and little c. Now remember, big A is the angle, little a is the side length, and same for B and C. So for the law of cosines, it's actually going to be the same triangle, so I don't know why I got rid of the last one. But basically, you got the same triangle, three angles on the inside, none of them have to be 90 degrees, and you label them the same way that we did before. The side length that has the same letter is going to be on the opposite side of the triangle with respect to the angle. Okay, so we've got angle A, angle B, side B, angle C, side C. Alright, so it's the same triangle, and the law of cosines looks like this. Now, I learned it one way. I'll write it the way that I think I've seen more often on the internet, but both are completely valid. It's just I've written different letters in different places. So, the cosine law looks like this. C squared equals A squared plus B squared minus 2AB times the cosine of angle C. Alright, I'm going to write that down here a little bit better. C squared equals A squared plus B squared minus 2AB cos C. Okay, so here what we're looking at is C squared, A squared, and B squared. These are all the side lengths. Okay? So this C squared, A squared, and B squared are all in relation to the lengths of the different sides. And it's actually the same thing with this A and this B. There's only one time an angle actually appears here, and it's at the very end, cosine of angle C, big C. So you can write it this way if you wish. The way I learned it was just the letters were in other places. So I had an A squared here, I had B squared and C squared, and then this, instead of AB, said BC, and that was angle A. But, so don't worry about that. The reason I liked my way is just to kind of just went in order, A squared, B squared, C squared. I just liked it that way. But this doesn't make any difference because you can use it for any side. So this is not specific to side C. If you wanted to, you could have the same thing with side A, for example. So let's say you could have the same thing as A squared equals B squared plus C squared, that looks like an E, minus 2BC times the cosine of big A, of angle A. Alright, so this is the exact same thing. This is not a separate law. This is the exact same law. I've just changed it to solve for a different side length. Okay? And the last thing you could write it as is with B instead of A. So you could also write it as B squared equals A squared plus C squared minus 2AC cos B. Don't really write it that way. You won't see that in most places on the internet, and I didn't learn it that way, so I'm never going to write it like that again in this unit. But those are the three different sort of permutations that you could have for whether, depending on whether you're looking for side A, side B, or side C. Okay? Let's leave it at this one. C squared equals A squared plus B squared minus 2AB cos C. So you can use it in this form if you want to figure out the side length, right? Let's say you have all of this other information. So what information do you need? If you're looking for C squared, this is the thing we're trying to solve. So that means we have to have the length of side A, we have to have the length of side B, and we have to have the angle C. We need to know these three pieces of information, and then we can solve for the side length over here. Okay? Now, what if you didn't want to solve for a side, but you wanted to solve for an angle? Well, all you'd have to do is rearrange this formula. So let's do that. Let's say we didn't know angle C. Let's say we didn't know angle C, but let's say instead we did know side C. We know all the sides, but none of the angles. Okay? Now, to do that, basically what we want is we want to get cosine C by itself on one side, and we want to throw everything else onto the other side of the equal sign. Now, because we're subtracting this whole thing, I'm actually going to move this over there. Okay, I'm going to move this whole chunk right here. I'm going to add it to both sides. So I'm going to do this plus 2ab cos C, and over here I'm going to have c squared plus 2ab cos C. Okay, that way on this side it'll all cancel, and on this side I'll have the same thing but with a plus sign. Nobody likes working with negatives. Okay, so I have now my next line is c squared plus 2ab times the cosine of angle C equals a squared plus b squared. Right, that's all I have because the rest of this got cancelled out from the right side. So now I have c squared plus 2ab cosine C equals a squared plus b squared. But I don't want c squared over here, and I've got something being added and something being multiplied. So the first thing I'm going to do is I'm going to get rid of this thing that's being added by subtracting c squared from both sides. So if I do subtracting c squared from both sides, that means this will cancel. So what I get is, let me write it up here. What you get is over on this side you've got 2ab cosine of angle C, and that's it because the c squared is gone. But on the other side you've got a squared plus b squared minus c squared. Okay, you see how that works? Because we had to subtract it from both sides. So a squared is positive, b squared is positive, and then c squared we're subtracting. Okay, so this bit is a sum, and then we're subtracting c squared. Now we're almost done because we want cosine of c by itself, but we've got this 2ab over here. But because it's all being multiplied, we can just divide both sides by 2ab. Like so. And what this leaves us with is our final form of the cosine law when you're solving for an angle, which is cosine of angle C is equal to a squared plus b squared minus c squared divided by 2ab. Okay, hopefully that's making sense. So this is what we've got. We've got this, if you're, oh that's a horrible line. We've got this, if you're trying to solve for an angle, and we've got this if you're trying to solve for a side. So those are the two variations of cosine law. Okay? So, if you have two sides and an angle, and the angle in between specifically, so if you have angle C and you've got these two sides on either side, you can use that to figure out the length of this side over here. And if you have all three sides, then you can use this version to figure out any one of the angles on the inside. Now, cosine law looks a little bit more complicated, especially this one, looks a bit more complicated than sine law from before. So you don't actually need to do this 3 times to figure out the angles. Let me show you what I mean. If you have, so let's forget about this right now because we're not worrying about this just yet. In our next lesson we'll practice a bit more, I think. That's my plan right now. It might change, but we'll see. So basically, you've got your first, if the first time you know side A, sure, you know side B, you know side C, but you don't know any of the angles. So your first task is to use cosine law like this to figure out angle C. Alright, now once you've got angle C, you could use cosine law again to figure out angle A or angle B, but look, you've got side C and you've got angle C. You could just use sine law. Sine of angle C divided by the length of angle C equals, well, whichever one you're looking for. You could do sine A over A or sine B over B. And of course with sine law, because we're looking for the angles, you can leave the angles on top. If you happen to be looking for a side, you're allowed to write it upside down, like so. You just need to make sure that you write both of them upside down then. Okay, you can't just do it to one. So you could do sine law. So you do cosine law the first time to get one angle, and then you do sine law, let's say, to figure out this angle. And now you could do cosine law to figure out angle B. You could do sine law to figure out angle B. Or, well, you know A plus B plus C is going to be 180 degrees. And you already know A, and you already know C. So all you have to do is 180 minus A, minus the measurement of angle A, minus angle C, will leave you with the measurement of angle B. And that allows you to, given all three side lengths, that allows you to figure out all three angles. Okay? So I know this is quite a lot to take in, but what I don't want to do is just throw random numbers out there and have ugly looking answers like the 5 times the square root of 6. So what I'll do is before the next video, I'll plan out some questions that give you some nice numbers that you can see how this whole thing works, okay? So this is how cosine law works. You have this form for the angle, the other form that we wrote down for the side, and then we also have sine law. So now you can use these properties. As you can see, even though we originally got sine, cosine, and tangent from right triangles, you can use them for any triangle. None of these angles actually needs to be exactly 90 degrees. You can you can use those for any triangle, and it should, as long as you don't make a mistake, it should give you the right answer. Okay, so if you have any questions, let me know. I'm a couple of minutes short for this one, but maybe you guys could use that time to just re-watch some of this if you need to. But otherwise, in the next video, I'm thinking I will give you guys some practice questions. Maybe I won't make it in a video, maybe I'll do a worksheet, but we'll see. One way or the other, the next video will be working with sine law and working with cosine law, so that you can get some practice and get a feel for how this whole thing works. Please do remember to start bringing a calculator if you don't already, because this kind of thing is only easy to calculate for some values, and it's more difficult to calculate for other values. You'll notice that if the angle was 30 degrees, I'm more than happy to do the calculation. If the angle's 75 degrees, I'm not doing it, because I haven't memorized that one. So it's very handy to bring a calculator, and because there will be trigonometry on the exam, I'm going to let you bring a calculator for the exam. So get a calculator if you don't have one, bring it if you have it and you haven't started bringing it yet, and take some time to get familiar with it. You don't want to step into the exam with your scientific calculator for the first time and not know where the cosine button is, or not know where the sine inverse button is. You want to be able to figure those things out before the exam. Alright? If you guys want some help figuring out how the calculators work, if you haven't figured it out yourselves, then let me know and I can do a short video explaining how all of that works. Otherwise, yeah, let me know if you guys are having any problems. I know this is a little bit advanced. This is grade 11 math, which is several years ahead of some of your levels, but I think if you take your time and really try to understand it and try some problems, that you'll really start to get it. So hopefully this is working, and I will see you in the next video.